Good morning. So welcome you to attend today's lecture. Today we are going to study session 3. Session 3 is about the IoT. So far we have already studied session 1, which is about the basics of robotics. And we have also studied session 2, which is about the basics of automation. Actually, you could consider robot as a mini version of IoT, and also you could consider the manufacturing system, production system, automation system, and the control system as an example of IoT. So therefore, these 3 topics are related. Now we start to zoom into the detail, okay, inside IoT. And later on, you will see the 3 basic building blocks of IoT include microcontroller, sensor, and actuator. Because with the use of a microcontroller, you will be able to build up a network that is the internet. And with the use of a microcontroller, you should be able to interface with the sensor, with the actuator, and many other input-output device. All right. So the pillar underneath IoT should be microcontroller, sensor, and actuator. All right. So today we are going to spend 3 lectures to cover today's session. And lecture 1 is for you to know, have a big idea about what is IoT. Then subsequently, we are going to study these 2 basic communication methodology. These 2 methods are underlying all the advanced communication network. All right. So let's start lecture 1 in session 3. All right. What is IoT? So in order to understand IoT, you need to know what is a network is the system or interconnected system through the use of a network. Then you understand what is IoT. Then you may want to know, why do we need to have IoT? Okay, the easiest answer is to know what are the possible application with IoT. All right. Then you need to know, okay, how to study IoT, how to master, okay, the fundamental or basics of IoT. Then the answer should be, what should be the engineering foundation, okay, underlying IoT, all right? Then we just talk a little bit about the future challenge or faced by IoT, all right? Like give you overview about the IoT. Then subsequently, we are zooming into the detail of how to build up a network, right? How to interface with the sensor, how to interface with the actuator, all right? Because this topic is quite big, this is why we are going to spend 3 sessions in order to have a basic understanding about the IoT. So let's start with the answer to this question. What is a network system? All right. And here you will see, before you can understand what is a network system, you need to know what is a system. All right. When we study session 1, roughly we know the definition. A system basically consists of interconnected, interrelated element which add together for the achievement of a common goal. For example, you have a car. Inside the car, you have an engine, you have a wheel, you have a chassis, and you may have many other sensors, etc. Right? So all these elements are interrelated, interconnected together. Right? Then you may want to know, then what is a network in the system, all right? The simplest example for you to understand what is a network system is to look at the feedback control system. So you remember in session 2, when we study control system, so we know that the inside control system, we have 3 basic building blocks. One is a system under control, second one is a sensory feedback, and the third one is a controller. Actually, all these 3 basic building blocks could be connected with the use of a network. All right. So in that case, if we use network to link a system under control, sensory feedback, controller together, then you have a network in the system. All right. But we can extend this simple example to a massive number of actuator, massive number of a sensor, and a massive number of a controller. Then you have a networked system in which you see the presence of a controller, sensor, and the actuator. Right? So that gives you idea, okay, about the definition of a network system. All right, just extend what you have studied in session 2, in which the third lecture is to let you know what is a feedback control system. All right, so you extend that. Okay, instead of a single actuator, single sensor, single controller, now you just imagine you have many sensor, many actuator, many controller, which are linked together. All right, then the result will be a network system. All right, so it's quite straightforward. Okay, if I ask you, okay, to name some typical network system in the physical world or in your surrounding, all right, and it should be quite easier for you to give the answer. And this video basically showing you a robot is a complex system, right? So you can imagine the finger, all the finger coordinate together is a network, okay? And the robot has a 2 arms, 2 legs, and the body, all right? So robot itself is a network system, all right? And you can also, okay, find many examples in factory, in home, hospital, school, and the city. So I give you a group project assignment. So actually, the assignment for your group to undertake basically is to describe, okay, solution of IoT, either in factory, home, hospital, school, or city, etc. All right. So this slide may help you to plan the group project, okay, assigned to you. All right. And now I just quickly go through some typical scenario of a network system. For example, in this case, we have a network which link a server together, and we have a workstation, and we have a controller, you see, and we may have central controllers here, all right? So through the use of a network, we can link all the computing unit together, all right? And here you see in the factory floor, we may have a lot of computer controlled machine automation equipment. So you see all these are the automation equipment, all right? Then through the wireless connection, all this equipment could be linked together. And here you see the presence of a robot, 3 robotic arms, all right? So you can link them all together. So then in this case, this is a typical scenario of a network system in the factory, all right? And here in the home environment, eventually you may have automated door, surveillance camera for security, and automated window, all right? On the automatic controller, all right, or remotely control the window, etc. And also you may have a sensor to monitor the water supply, electricity supply, and the gas supply, etc. You may have a sensor to monitor the movement of the people inside the house, etc. Then all these actuator sensors are interconnected together, all right? So then you have IoT, all right? A network system in the home environment. Then in the hospital environment, so you see, we may have, for big hospital, we may have a lot of operation theater, all right? A doctor operates a patient, all right, inside the operation theater. And besides that, we may have a room for the patient to stay, all right? And in the city environment, usually you may have many hospitals. It's not just single hospital, because for a single hospital, you may have a lot of such surgical room, okay, operation theater. And inside the city, you may have many hospitals. Then all these hospitals can interchange data about the patient, because a patient can visit hospital A in one day, then few months later, he may visit hospital B, all right, for another sickness or illness, all right? So this is why it's important for the hospital to exchange information, exchange data, all right? So that's the typical scenario. But eventually, for the environment which are familiar to you, because you are a student, then you know the school, all right? So inside the school, we have a lot of lecture theater or classroom, all right? And today, all the classrooms are more or less equipped with IT equipment or IT facility, all right? For example, we have a computer, we have a projector, etc. Let all these are linked together to the server. So therefore, through the computer, we can access to the course material, etc. Right? So this also gives you idea about the network in the system. Then of course in the city, then it's more complicated, right? So in a city environment, you may have a factory, you may have a power supply plant, and a water supply plant, transportation system, administration system, like school and the factory, etc. All right, so it's very, very complicated. When you talk about the transportation system, and a vehicle could be considered as an actuator or sensor, right? So all the vehicle can link together, because we can mount sensor on the vehicle, okay, to measure temperature, to measure humidity. All right. So actually, vehicle is a very good a platform for us to achieve a mobile network of a sensor. All right. And today, I believe we do not leverage on such capability. All right. So because each vehicle can carry temperature sensor, humidity sensor, yes or no. Then we collect all the data. Then we have a real-time distribution about the temperature in the city or in the entire country. All right. So that gives us a more accurate information. All right. So you ask yourself, for those of you, you have a car at home. How many of you have a car which have a temperature sensor, humidity sensor, which could send the data to a server? I guess should be zero. Yes or no? All right. So you see, this is an area in which you can do some project, then help the government to collect very, very accurate data about the temperature distribution and the humidity distribution in the city, in the province, in the entire country. All right. So you see, IoT is very important. All right. Okay. So now we zoom into this definition. What is exactly IoT?
The Internet of Things is changing much about the world we live in, from the way we drive to how we make purchases, and even how we get energy for our homes. Sophisticated sensors and chips are embedded in the physical things that surround us, each transmitting valuable data that lets us better understand how these things work and work together. But how exactly do all these devices share such large quantities of data, and how do we put that information to work? Whether we're improving the production of a factory, giving city residents real-time updates on where to park, or monitoring our personal health, it's the common Internet of Things platform that brings this diverse information together and provides the common language for the devices and apps to communicate with each other. The process starts with the devices themselves, which securely communicate with an Internet of Things platform. This platform integrates the data from many devices and applies analytics to share the most valuable data with applications that address industry-specific needs. Let's start with a simple example, a car. After taking a long road trip, Rebecca notices that her check engine light has come on. She knows that she needs to have her car looked at by a mechanic, but is not sure whether it's something minor or something that needs immediate attention. As it turns out, the sensor that triggered Rebecca's check engine light monitors the pressure in her brake line. This sensor is one of many monitoring processes throughout the car, which are constantly communicating with each other. A component in the car called the diagnostic bus gathers the data from all these sensors, then passes it to a gateway in the car. The gateway integrates and sorts the data from the sensors. This way, only the most relevant diagnostic information will be transmitted to the manufacturer's platform. But before sending this organized data, the car's gateway and platform must first register with each other and confirm a secure communication. The platform is constantly gathering and storing thousands of bits of information from Rebecca's car and hundreds of thousands of cars like hers, building an historical record in a secure database. The manufacturer has added rules and logic to the platform. So when Rebecca's car sends a signal that her brake fluid has dropped below a recommended level, the platform triggers an alert in her car. The manufacturer also uses the platform to create and manage applications that solve specific issues. In this case, the manufacturer can deploy an application on the platform called the Asset Management System. This application oversees all of their customers' cars on the road, as well as all the parts in their warehouses. It uses the data from Rebecca's car to offer her a potential appointment time to service her car, directions to the nearest certified dealer, and a coupon for the service. What's more, the app will ensure that Rebecca's brakes are covered under her warranty, that the correct replacement part is ordered, and then sent to the dealership so it is ready when she arrives. But the manufacturer's analysis does not stop there. They have also deployed a continuous engineering application that tracks not only Rebecca's car, but hundreds of thousands of others, looking for ways to improve the design and manufacturing process of the car itself. If the same problem in her brake line crops up in a critical number of other cars, the manufacturer uses applications custom built for the automobile industry to pinpoint the exact problem. They can see if these cars were made at the same factory, used the same parts, or came off the assembly line on the same day. So what do all these pieces add up to? Streamlined inventory management for the dealer, a better, safer car from the manufacturer. And for Rebecca, it means she can be back on the road faster and get to where she's going safely. All thanks to the Internet of Things.
Okay, so you see the benefit of implementing IoT for the maintenance of the car, all right? So video basically showing you that scenario, all right? So then what is IoT? IoT basically is a network system, all right? But the focus is on the network and the sensor. And here the sense refer mainly to sensor and the actuator. So these are the three pillars underneath IoT. So you have a sensor, actuator, plus controller, all right? Because through the use of a controller, you can build up a network. Through the use of a controller, you will be able to interface with the sensor. Then through the use of a controller, you will be able to interface with the actuator, all right? So that is IoT. But interestingly, for those of you, if you do a little bit of study of a religion, we may talk about the IOL, Internet of Life, all right? But this sense exists in the universe. Very interesting, all right? Okay, so then from here you see there are three keywords, three pillars, all right? So this is why we are going to spend 3 sessions, because we need to know what is a controller. We need to know what is a sensor, how to interface with the sensor. Then we need to know what is actuator, how to interface with the actuator, all right? For today's session, we focus on the study of network or controller, microcontroller, and how to build up the network with the use of a microcontroller. But actually, you need to spend an entire semester to study microcontroller. I hope that in today's session, you will know the basics about the microcontroller, all right? That motivate you to take up the microcontroller courses so that you have more understanding in the microcontroller. So basically, microcontroller cover programming and the interfacing. Programming, then you need to know what should be the instruction, all right, programming environment, how to input the data, how to output the data, how to process the data, all right? So that are the basic skill, okay, for you to understand programming of microcontroller. Then in terms of construction of the hardware, then you need to know interface with the input device interface with the output device. The typical input device will be sensor. The typical output device will be actuator. All right. So in session 4, we will study input device. All right. Session 5, we will study output device. All right. Then today we just cover the basics about the use of a microcontroller to build up the network. All right. Then you have a good understanding about the IoT already. All right. But if you want to know more in detail about the microcontroller, then you need to study entire course dedicated to microprocessor system, etc. All right. Then this one just give you a rough idea about the blueprint of a microcontroller. So inside here, you just pay attention to memory and ALU. But all these put together, basically, we call them as a CPU. Basically, ALU plus control unit, we call them as a CPU, central processing unit. Then you have a memory. So inside the memory, for those of you, if you have a study computing system, then you know. For those you have not yet studied, or you do not know what is a digital computer, so you just imagine memory is like a hotel. Inside the hotel, you have a room. Each room has an address, John. Okay, it's like 301 means the room is at the level 3, number 1. Or 310 means level 3, room 10. So it's the same, okay? So memory, you just imagine it's a hotel for the digital binary number, okay? Because computer today, they can only, at the lowest level, they only know 0, 1, right? Then with the use of 0, 1, then we can, through the encoding, decoding, we are able to represent any mathematical number, all right? So at the lowest level, we only have a 0, 1, 0, 1, all right? So let me see in terms of hardware, just imagine memory is a hotel with many, many rooms, and each room will only house a digit, because a digit put together, we call them as a byte. So you just have this basic understanding is good enough, okay? One room could house a digit, all right? Each digit will be either 0, 1, and this a digit put together is 1 byte, all right? Very simple. Memory is a hotel room, okay? Which contain a digit or 1 byte. It's like one person can stay inside a room, okay? So it's a single person room, special hotel, okay? Single person room, a single person correspond to single byte. That's it, all right? Then ALU is very easy for you to understand. So it's a device which can do arithmetic computation, logic computation in mathematics, or addition, multiplication, division, subtraction, etc. All right? So just imagine in this way, done already. But if you want to know more detail, then you need to study this course, all right? The good news to you is today the most popular microcontroller is ARM microcontroller, because it is cheap, it is powerful. That means this hardware give you the best performance to price ratio, performance divided by price. Okay, they give you the best ratio, all right? It's very performant, it's very powerful and very cheap. Therefore, you compute the ratio, you get the big number, all right? So this is the best hardware today, okay? And your handphone, I guess all your handphone, besides those with iPhone, if you have an Android smartphone, and inside basically is an ARM microcontroller, all right? Okay, so it's very straightforward. And in case if you want to have a dedicated hardware for you to play with IoT, then this is one example of a product. And good news is actually with the use of MATLAB together with your laptop computer, you can form an IoT network. So it's, and for university student, I guess MATLAB is free. Okay, you can get MATLAB for free. So MATLAB plus your laptop, then you have IoT already. All right, okay. So And just now you may see, okay, IoT is extremely important because a lot of benefit, because once everything linked together, then we know each other, and also the equipment know each other. All right, if something fail or something need to be changed, then we know in advance. All right, so there are many benefits. All right, so then besides that, what are the other possible application? All right, so actually, I guess IoT in future could exist everywhere, right? So it's like the whole universe. For those of you, if you study religions, all right. So actually, in the world of life, everything is linked together. So there's Internet of Life already, IOL. Okay, it's already in the universe. Now on Earth, okay, we universe. We try to build the IoT. All right. So eventually, it will be everywhere on Earth or everywhere in the universe. All right. So, but here I just highlight, okay, some typical application just for you to know, right? And this slide basically you see, okay, for every system which are related to our life, daily activity, make our life easier because we need to do the shopping, banking, and education, to work, etc., or to travel, all right, entertainment. All these activity could be implemented with the use of IoT technology. All right, so this slide basically telling you, okay, so you can apply IoT everywhere. All right, so it's quite straightforward. For example, in a restaurant environment, okay, so you can have link up all the okay all the people involved inside a restaurant, because the people involved in the restaurant include the owner, the chef, right? The waitress, okay, the service person, and the customer, etc. All right, so you can link all this together. All right, so it's easier for you to order the plate and set the bill, okay, after your lunch, after your dinner, etc. All right, so here this video basically highlight to you an example. Then you may implement IoT integrated restaurant in future, right?
We're here at Spice Robotics. Spice is the brainchild of Bohr and Leipzig, who think that by replacing line cooks with robotic chefs, they can make restaurant jobs easier and healthy food more affordable.
We started Spice when we were college students living a college student budget. The idea came about because we felt as though we couldn't get a wholesome, really great meal at an affordable price. All our bowls are $7.50. Using the technology, we're able to be really efficient and therefore deliver that value to the consumer. As soon as you walk through the door, you get your first glimpse of the Spice Robotic Kitchen. From there, you reach our ordering kiosks where you enter your meal. From when you place your order to when you get your meal should take around 3 minutes.
All of the recipes are developed by human chef Sam Benson.
So here we are at the ordering station.
This is pretty intuitive. It looks like we're just going to tap it to start.
You'll see we have 4 sections. All of them vegetarian, vegan, gluten-free.
Well, I eat everything.
Excellent. So do I.
How is it different to cook with a robotic kitchen than it is to cook with your hands on the stove?
When I had to make the menu, we made it very broad for customization and for a lot of different choices. I had to apply basically one cooking technique to everything, which is roughly sauteing.
I'm going to try that out.
I always suggest customizing because you can put your own twist on it, and we allow you to put your own twist on it without messing it up.
So what's something that you wouldn't let me add to this bowl?
Something I wouldn't let you add to this bowl would be our tamarind date chutney that goes on our tikka masala bowl. It just wouldn't.
This looks really good to me.
So this is our cucumber salad.
I'm going to add that on as well.
Yeah, absolutely. You have the choice of your grains.
This is our order. Spice serves warm grain bowls topped with vegetables and sauce. To get it started, a robotic runner picks up the ingredients you selected from their individual hoppers. The runner stops at the wok that will cook your meal and drops off the ingredients. The grains are catapulted in by a cup measure behind the scenes. The woks are heated by individual heaters that use magnetic fields. Even though your food gets hot, the heaters stay cool to the touch. After a bowl is done cooking, the wok tips downward to plate the food. From there, a cook grabs it to put on the finishing touches. While that's happening, the wok tilts down and is hit with a jet of hot steam to clean it before it starts cooking the next meal. All allergens are kept outside of the woks, so there's no risk for cross-contamination. So I just got my bowl, give it a try.
Okay, should be good enough for you to understand, all right? The IoT integrated restaurant, then we may have an IoT integrated hospital, because in the hospital environment, we have a doctor, we have a nurse, we have a patient, and we also have the war room, surgical room, etc. All right, and the office, etc. So how to link all this in together, and especially we need to have a server to store all the data, and also we need to supply the food, supply the medication, etc. to the patient. All right, so how to interconnect all these activities together. All right. So therefore, we can deploy IoT, right? So let's say real-time data, smart device to assist a doctor to make a better diagnosis about the patient, all right? And also monitor the functioning of IoT, all right? Okay, turn the volume up a little bit. It's already maximum. Okay, we'll see. All right. Okay, so then I guess I have a video continue. And this video basically showing you a new facility, all right, in the new hospital. And this may give you idea, there are so many equipment for operation, so many equipment for diagnosis, etc. So obviously you must link all this equipment together. All right.
I'm ready. We make no secret of the fact that we are determined to head right to the top of medicine. That's what we're doing. This is a beautiful example of it. I saw a machine that I'd seen 7 or 8 years ago in a lab building in Germany at Siemens, which was now a reality. And when somebody explained to me how it was going to be used, what more can you say?
We had this vision of what we thought the future of the operating room should be and what the future of surgery should be. And having an administration that was supportive of this future vision, we were able to, with a lot of people's help, create these rooms, which are not only operating rooms that have the state-of-the-art technology, but operating rooms of the future, where we're going to actually change what surgery is.
We're the first hospital in the country to have 2 of these units in the operating room. Just the whole concept of what is surgery or what is needed to treat diseases is changing. We're going to redefine what a surgical specialist is even, because a surgical specialist now has to be an information technology expert. They have to be a radiologist, endoscopist. They have to be able to do minimally invasive surgery. They got to be able to do conventional surgery.
This revolution is really this merging of intervention with imaging equipment that allows us to be better surgeons and allows us to be minimally invasive surgeons.
In this room, at least 12 different image devices so that you can have multiple inputs.
It starts with the electronic medical record. Everyone has access to it. The surgeon has access to it. The anesthesiologist has access to it. The nursing team has access to it. We can communicate with the pathologist upstairs. We have the images from the endoscope, from the microscope. Everything can be viewed at by the clinicians and the people that are taking care of the patient, so we can get everyone's feedback instantaneously.
We are optimizing the patient's care by putting in the hands of the surgeons every conceivable piece of information in the room, helping the physician do the best job.
And it's not just the surgeon, it's the
Okay, that should be good enough for you to understand. Just one part of the hospital, the operation room, in which you see their output device, display as an output device. You also have actuator. You see the automated equipment, and eventually there's a surgical robot, all right, present in such an operation room, all right. Then how to link all this equipment together? So obviously you see the need for us to implement IoT in a hospital environment. Then for industry, it is more complicated, all right? So factory, a big manufacturing factory should be more complicated than a hospital, all right? So because we have many automation equipment, etc. All right. Obviously, we need to link all this equipment together. So this is a very good place for us to deploy IoT, right, in the factory. And here, even within the small production line, so you see we have a presence of a robot, presence of a logistic equipment like a vehicle, all right, and the transportation equipment, all right, and eventually we may have an inspection station, okay, for quality control. So you see we have a sensor, we have an actuator, then we need to link all this in together, all right. And this slide also showing you the area in which we see the presence of automated equipment and the sensor, etc. Then we need to link all this in together, right? So, and this is a short video for you to understand.
But now we're facing the next one, connectivity. But how can a company handle this? What does the industry of the future look like? Our experts have been wrestling with these questions for years. They know that the complete digitalization of the manufacturing industry plays a key role in the process. Why? That's simple. In the future, it will be more important than ever to operate quickly, flexibly, and cost-effectively. Product life cycles are becoming increasingly shorter, while product variants are becoming progressively larger. Just like large volumes, small quantities must be produced economically. Lead times will become shorter, so the delivery must become faster. For companies, this means that in the future, they must align their organization much more rigorously to meet customer needs. This can only be achieved if companies start today to digitize, automate, and above all, interconnect all processes. Not only within the company, but also along the entire value chain. This means a convergence of the various areas. Customers and business partners are part of the total process. The goal is to make all relevant data available anytime and be able to control the whole network of value creation in real time, from product planning and product and production development all the way up to production and logistics. Of course, data security must be assured at all times. Synchronizing digital and physical value streams not only increases productivity of companies, but also their efficiency, quality, and innovative capacity. The Industry 4.0 concept isn't new, but unlike before, we now have the knowledge and technology for it to become affordable reality. As you can see, the industry of the future presents us with many opportunities, challenges, and questions.
Okay, this should be good enough. And for those of you, if you have seen this terminology like Industry 4.0, actually Industry 4.0 means Internet integrated manufacturing. So Internet integrated manufacturing basically means what? Connectivity. And how to achieve connectivity? The answer is what? IoT, all right? So you see the importance of IoT for us to achieve the scenario of Industry 4.0, all right? So Industry 4.0 means Internet integrated manufacturing, all right? So that gives you stronger motivation to really master IoT. And in the agriculture area, all right, IoT will also play very important role because we need to monitor the condition for the plant, vegetable to grow. For example, monitor humidity, temperature, because these are the two very important parameters, all right? And normally a farm will cover a large area, all right? So then it is good to implement IoT a network of a sensor, and eventually network of actuator, because we need to supply water for the growth of a plant or vegetable. All right. And here, this slide basically showing you one more scenario. Here you see control of supply of the water or nutrition. Okay, besides the water, because the plant need also other type of chemical. Okay, in order to grow. So we call them as nutrition. All right. So then, besides the sensor, we must also have an actuator. You see, sensor actuator must be there. All right. And this video basically highlight to you, all right, how to transform agriculture into an industry. All right. So then into a high-tech industry.
Of leafy greens are growing in huge quantities to be sold to local supermarkets and restaurants. This is Aero Farms, a massive indoor vertical farm in Newark, New Jersey.
Our mission is to build farms in cities all over the world so people have access to fresh, great tasting, highly nutritious food.
Crops are stacked more than 30 feet high inside this 30,000 square foot space. They're grown using aeroponic technology.
Typically in indoor growing, the roots sit in water and one tries to oxygenate the water. Our key inventor realized that if we missed nutrition to the root structure, then the roots have a better oxygenation.
AeroFarm says the root misting system allows them to use 95% less water than a regular field farm. They also use no pesticides or herbicides. Instead of soil, plants are grown in reusable cloth made from recycled plastic. And instead of the sun, there are rows and rows of specialized LED lighting.
A lot of people say, sun, let's wait, plants need sun. In fact, the plants don't need yellow spectrum. So we're able to reduce our energy footprint by doing things like reducing certain types of spectrum.
This sophisticated climate-controlled system cuts the growing cycle in half, so crops can be grown all year round, but with a much smaller impact on the environment.
There's all these stresses on our planet. 70% of our freshwater contamination comes from agriculture. About 70% of our freshwater usage goes to agriculture. 1/3 of our arable land has been degraded in the last 40 years. All these macro trends point to the fact that we need a new way to feed our planet.
One of the early champions of vertical farming is Columbia University ecologist Dixon DePommier. In 1999, DePommier and his students proposed that vertical farms could feed overpopulated cities while using less land and less water. They would also cut greenhouse gases by eliminating the need to transport food over long distances. And the idea is finally taking root. Over the past few years, vertical farms have sprouted all over the world, including in Vancouver, Singapore, Panama, the UK, and around the US. Here in Newark, Aero Farms is building out another new farm in a former steel mill, one that's bigger than a football field. Once it's fully operational, it's expected to produce 2 million pounds of greens a year, all grown vertically.
We listen to the plants very carefully to try and understand what they're telling us and try and optimize all these different qualities of the plant. It's a tough business, but it's one that's going to stay and it's going to have a bigger and bigger impact.
Do you think vertical farms will
Okay, so this should be good enough. So you see, this is a very interesting development, all right? Instead of having a field farm, then we have a vertical farm. And from the IoT point of view, you see, we need to supply water, nutrition, but also the lighting. So actually, we do not need to have a sunlight channel. We need to have indoor controlling the lighting. It should be good enough for the plant, vegetable to grow, all right? So this is a very interesting area of application. But of course, in a city area, even inside the factory, we need to also do the disaster management, all right? To prevent fire, in the forest, fire in the city, breakout, or fire inside the factory, etc. So the disaster management system must be deployed in the factory, city, and even in school or hospital, all right? So you see, then we need to have a network sensor to monitor the smoke, the fire, and the other presence of toxic chemical, because they may have presence of a toxic chemical. Okay, so we need also to monitor all the quality of air, etc. Right, and then this is showing you the scenario of doing disaster management in the city environment. All right, the breakout of a fire, the presence of a toxic chemical in air, and accident on road. All right, because they may have a collision or whatever. All right. So then we need to have a massive network of a sensor in order to achieve this goal. All right, so it's quite straightforward. Then in future, everything must be interconnected together. So in order to make our life easier, when you do the booking of your ticket or train ticket and the airplane ticket, etc., or you order food or other object, then you see there's an internet, all right, which will help you to undertake such a network-based activity, all right, okay. And here also you see the future scenario. In future, we may have IoT for the street lighting, IoT for smart parking, IoT for the building, smart home, and smart health, right? IoT in the hospital environment, etc. Then public safety and the air monitoring system, etc. So you see, there are many areas in which we could deploy IoT. All right. So I hope that should be give you enough motivation to pay attention to the study of IoT. Then this short video basically highlight one of the scenario in future city.
70% of the world's population will be living in cities covering less than 2% of the Earth's surface. Never have cities been so challenged, and the trend continues to grow. This raises many issues: pollution, infrastructure access, traffic congestion, mobility, safety, and the health of residents are only a few examples. The development and combination of new technologies, such as the Internet of Things and artificial intelligence, offer a multifaceted solution: the smart city. Smart cities are hyper-connected cities, technologically equipped to improve the lives of their residents. In Mexico, some neighborhoods are still struggling to get permanent access to electricity. So the city installed sensors to analyze the use of electricity in various sectors, so as to optimize energy distribution across the grid. As a result, less frequent power cuts and better distributed energy. In the United Kingdom, the city of Bristol created the Data Dome, a public platform where information on traffic, air quality, noise, or even the city's governance can be shared. They want to grasp the city's pulse by exploiting this data and give local players, citizens, and entrepreneurs the means to build the smart city that truly suits their needs. At AXA, we want to provide our know-how to enable public authorities, businesses, and society as a whole to better anticipate the future and thereby protect all actors living and creating the cities of tomorrow.
Okay. So this video basically show you one vision about what should be the future city in year 2050, all right? And in which you see, IoT, AI will play a very important role for us to achieve that scenario of a future city, right? Okay. Now you see all these exciting applications waiting for you to develop in future. Then you may want to know as a student, all right, what should be the basic knowledge skill for you to acquire in order to become expert in the area of IoT, all right? In other words, what should be the engineering foundation of IoT? And actually already mentioned to you, you just remember these three pillars of IoT: controller, sensor, actuator. And on top of these three pillars, then there's a software, a layer of the software. That is good enough already, all right? So then in this section, then I just convince you about the importance of controller, sensor, actuator, plus software, all right? And here you will see, this is a viewpoint from the general public. So you see the presence of a sensor, presence of an actuator, and controller. I guess all this you can link together is a microcontroller, because interface, how to interface with the sensor, how to interface with the actuator, all right? And make them to be deployed in the network. The only device is a microcontroller, all right? So now you see these are three pillars, all right? Sensor, actuator, microcontroller are the three pillars. Then on top, you just have a layer of software, good enough already. Then once you have a software, then you can talk about the data center, all right, database, etc. Because edge computing means you can undertake, because microcontroller itself is a digital computer, so you can undertake processing. This is why you see this. Because some of you may not be familiar with this special term, okay? Edge computing means computation, or edge IT is a computation at the node, okay, inside the network, because the network have a lot of nodes, okay? So each node has a computational capability. That's it. So it's quite straightforward. And here you see a layered view, right? So at the bottom, you must have an IoT device. So IoT device. So you see here we can consider robotic arm itself as a mega actuator. A vehicle itself could be considered as an actuator or sensor. Because a vehicle, when you move, the vehicle can measure temperature, humidity, noise level, all right? So a vehicle, you can treat as a mega sensor, all right? A robot is a mega actuator, all right? So all these are IoT device. Then on top, we have a software, all right? First, software basically is for you to establish the connectivity. So this is why in today's session, we will study the two basic technology, all right, at the bottom level, okay? So all the high level communication like HTTP, MQTT are built on top of the communication at the lowest level. So we will study synchronous communication, asynchronous communication, okay? So these are the basic things. With these two basic technology, you are able to define or invent your own protocol of communication at the higher level, all right? So today we talk about HTTP, you can say XTTP, X may refer anything, up to you, all right? So it does not matter. But at the bottom, the methodology remains the same and change, only change is at the higher level, all right? Then slowly, then you can go to higher level all the way to application level, all right? Okay, so let's give you a view about the IoT system. So basically, so you have a sensor, controller, actuator, plus software, that's it, all right? So we move on. And then in terms of the sensor, okay, what are the typical example? Then from here, then I just give you idea about the sensor. So actually, you need also to spend at least one semester to study a full course about the sensor, all right? So we may have ultrasonic sensor, infrared sensor, sensor to measure the gas, and measure the light. Photodiode is to measure the light, and then to measure rain sensor means to measure the humidity, and the proximity sensor measure the distance, etc. Right? So, and also we may have a sensor to measure the air quality, the presence of a chemical in air, in water, or whatever. Right? And also to monitor the smoke, humidity, lighting. Okay, the water level, okay, and the force, torque, pressure, temperature, humidity, acceleration, motion sensor, etc. All right. For actuator, it's the same. You need to spend eventually one semester to study a full course about actuator, because we have three types of actuator. At the low basic level, we have electric actuator, pneumatic actuator, hydraulic actuator. Then as I mentioned, once you use actuator to design complex machine, then the complex machine could be considered as a mega actuator. It's like this picture showing you robotic arm could be considered as a mega actuator, all right? So this is why you need to spend at least one semester to study the course about the actuator. And this slide basically showing you for any automated equipment could be considered as a mega actuator or mega sensor as well. All right. So you must enlarge your view about the IoT. Okay. Then some of you, if you are going to do research, you may want to know what are the future faced by or future challenge faced by IoT. Then in this case, because IoT has a 3-pillar microcontroller, sensor, actuator, then basically just look at what should be the challenge faced by sensor, by actuator, by microcontroller, all right? But once we put all the sensor actuator together, we have a robot. If let's say we consider a robot as a mega actuator, actually robot can also do the sensing because robot can undertake constrain the motion. There's an interaction with the environment. So we can consider robot as a mega actuator and also a mega sensor. All right. Then in this case, then you will want to know what is the future challenge faced by robot or robotics. So future challenge, I guess, is the same, is AI or machines self-intelligence. How to have a smart sensor, smart actuator. So we must incorporate AI technology. All right. So it's easier. Then for automation system, because for automated equipment, we can also treat them as a mega actuator, mega sensor, all right? So this video may give you a rough idea, okay, more detailed idea about the industrial 4.0, all right?
New technologies are changing the world. They're also making the cars manufactured by the Volkswagen Group more efficient, safer, and more customer-friendly. The nature of car manufacturing is also changing in a similar way. In fact, the next batch of innovations is so extraordinary that experts are already declaring the dawn of a new industrial era, Industry 4.0. So what does manufacturing look like today? Traditional car production involving hundreds of identical vehicles lined up in a row no longer exists. The options available to customers are now so vast that each car becomes a unique and individual object. Cars are now manufactured to order. Data makes its way from the customer's order to the Volkswagen Group's systems and then to each individual section of production. A car consists of many thousands of individual parts. The press shop processes blanks for the bodywork. In the body shop, the car is baptized. In other words, it's given an RFID tag that can track it via radio frequency. This establishes which car body belongs to which customer order. The paint shop also receives information from the system world. In sequencing storage, the cars are placed in an optimal order for assembly. From here, information is transmitted to suppliers and reassembly as to which part is required when and where. In final assembly, the finished car emerges. The Volkswagen Group manufactures its cars using state-of-the-art technology, but development and innovation never stop. What does the future hold in store? Today, everybody is talking about Industry 4.0. It is a term used to describe a variety of innovative production processes. But what exactly does it mean? The Volkswagen Group has been shaping the future with groundbreaking projects for many years. Here are some recent examples. Digitalization. The digitalization of all elements of production is essential for a new era in industrialization. Everything is given a virtual likeness in the system world. The result is an Internet of Things. Example, 3D printing. Pressing tools are no longer shaped in a laborious manner. Instead, these tools can be made from steel granulate in a 3D printer. It's a technology that opens the door on completely new possibilities for design, with a level of precision unknown until today. Example, human-robot cooperation. In the past, protective grids separated robot arms and employees. In the future, employees and robots will work increasingly hand in hand. This is made possible by new security sensors. Robots take on especially monotonous and arduous activities. Today, robots already play a part in contributing to ergonomic workplaces at the Volkswagen factories in Chemnitz and Salzgitter. Example, big data monitor and logistics. The big data monitor enables for the rapid visual processing of data from the 1,200 suppliers of the Audi factory in Neckarsulm. Where are the potential bottlenecks? Where is the greatest need for action? This data is now easily accessible at all times. The intelligent factory of tomorrow paves the way for efficient and cost-effective production unlike ever before. Industry 4.0 also means brand new opportunities for employees. The Volkswagen Group has already begun actively preparing its workforce for the future. The world is changing, not only in the automotive industry. Everything is in motion, and the Volkswagen Group provides the...
Okay, so let's give you an idea about the current practice and a little bit the future trend, all right? Then, okay, so basically this slide summarize, okay, a little bit about the future challenge faced by IoT. Because once you deploy a massive network of a sensor actuator, then these are the three issues. One is energy consumption, because a lot of sensor, a lot of actuator, all right? So you need to have a low power consumption in order to make your IoT sustainable. Okay, if you need to consume a lot of energy, then okay, the cost will be high. Another one is about security, because you have a massive network, then the capability of the network is very powerful. But if someone hack into the network and use your IoT to do something which could damage your environment, damage your factory, then that should be a concern, all right? And another issue, third issue should be the real-time response, because you have so many sensor actuator which are distributed into a large area. How to achieve a real-time response, all right? So these are the three major challenges faced by IoT, all right? Okay, so let's talk about this first lecture, okay, of today's session, okay? So this first lecture gives you introduction about the what is IoT, what are the possible applications with IoT, what are the engineering foundation of IoT, and a little bit about the future challenge faced by IoT. We take a short break of maybe 8 minutes, so we start at 10:20. All right.